here are the free response questions came in the past years. Let's practice one by one. You can watch my previous video also where I have gathered different kind of the free response questions and explained that how can we solve it in the easier method. Now let's try to understand this question. In the question, the table is given. The most important thing when any question is comes in front of you, in order to solve or apply the Riemann sum. To solve that, always try to understand whether the width is equal or the width is uneven in the given scenarios. Okay, so let's here, if you look here, so they are saying that the volume of the spherical hot air balloon expands as the air inside the balloon is heated. The radius of the balloon in the feet is modeled by the twice differential function r of the time t, where t is measured in minutes for from 0 to 12 time interval of the time. Now why I have just marked it, because it is important for me to understand the situation of the equation. The graph is concave down. Okay, so the graph is concave down. Now the table above gives selected values of the rate of change r prime of t. And now what you have to find out, let's try to understand that what we are saying, that the volume of a sphere of the radius is given by this formula. Use the right Riemann sum with the 5 sub-intervals indicated by the data to approximate the values of this function, differentiable function. So 5 intervals, so 1, 2, 3, 4 and 5. Now check what do we write as a width. Okay, so in order to find or calculate the width, 2 minus 0. So 2 minus 0 is 2. 5 minus 2 is 3. 7 minus 4 is 2. 11 minus 7 is 4. And 12 minus 11 is 1. So this is how we calculated the area, the width of the rectangle. Okay. Now after that we have the r prime of t in feet per minutes, okay, which is the radius of the balloon in feet per. Okay, so how can we calculate it using a right Riemann sum? So when we have a right Riemann sum, I told you that we start from the right side and we go and go and go and leave the first value. Okay, so this is how we do the right Riemann sum. Now first of all, write the equation. So you have to find out 0 till 12 r prime of t dt, which is equals to, now you have 5 intervals. 5 intervals means x1 f of x1 plus x2 f of x2 plus x3 f of x3 plus x4 f of x4, and then the last but not the least x5 f of x5. Now in your scenario, if you want, you can write in place of x this t. It means, let's try to understand. In place of x1, I am trying to write t1, t2, t3, t4, t5, but only do when you are confident about your understanding. And now it is r prime of t. So here in place of f of x1, you write here r prime of t1. Then what you will write? R prime of t2. Then r prime of t3. Then r prime of t4. And in the end, r prime of t5. Now T1, T2, you will take these widths which are calculated by you. So again, I am writing the widths only. T2, 3, 2, 4 and 1. Now I have to write down the r prime values. So I have to start in the left Riemann sum from the beginning. So it will be 5.7. 4.0, 2.0 or only 2, and 1.2 and 0.6. Write it in the calculator and get the answer. Now look, once you calculate it, just go through the problem. What they are asking you to write the units of the answer. So whatever you have calculated, since you are finding out the radius, so the radius is feet. So you are trying to find out the radius, which is you have to calculate the amount of radius. It means you have the answer as only ft, that is feet. Okay, so the units of the radius are only feet. Don't write feet per minutes. The reason is that you are not finding the derivatives, you are integration you are doing. So integrating, the units are only feet. Now what is the meaning of this whole situation? So try to find out the answer from the question. So what you are calculating? The radius of the balloon in feet are when the time is given between 0 to 12. So this is what you are finding. The radius of the balloon in feet when time when the time is given in the interval of 0 to 12. That is about that is what the question says to interpret. Now the question is given again. You have been given a table and use a trapezoidal sum with 4 subintervals. So check 1, 2, 3 and 4 subintervals. And you have the depth of the water and you have to find out the area of the cross section of the river using the trapezoidal sum. So first of all, we know for the area of the trapezoid is half h b1 plus b2. And what is the h values? H values, it is actually the width of the rectangle. So which is given over here as an x value. 8 minus 0 is 8. 14 minus 8 is 6. 22 minus 14 is 8. Is 6, 7, 8. Okay. And 24 minus 22 is 2. What we have to calculate? We have to calculate the area. Okay. So in order to find the area of the cross section by using the trapezoidal method, what is the formula? First we write the half as it is. Okay. Now h. H means d, right? So we will write here x1. Then we have b1 plus b2. Then x2, we have b1 plus b2. So what is x1? x1 is 8. Then you have another interval, that is 6. Then again b1 plus b2. In the end we will solve. Then you have another x, that is 8. Then you have another x, that is 2. Now you have to add the b1 and b2. For b1 and b2, we take the first 2 points. Then the last point and the next point, that is 7 plus 8. Then you will take again the last point and the next point, that is 8 plus 2. Then again the last point plus the new point, that is 2 plus 0. Calculate it and get the answer. That's all. Now use a midpoint Riemann sum with 3 subintervals in order to find out the total amount of water that was pumped into the pool during the time interval of the 0 to 12 hours. Okay, so what you have to do, you have 3 subintervals. Look, from 0 till 12. If you will see that the width 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, the width is equally divided. So you have to use your formula B minus A over N. B is the last point, A is the first point. And how many subintervals are 3? So the width of each rectangle will be 4. So when you have the equal amount of width, you have to use the width from here. Now you have to use the midpoint formula. Okay. So the first interval 0 till 4. The second interval, what we will have? Okay, let's see here. From 0 till 12. Okay, the 4. So then 4. Then you will have the 8 and then you have 12. So 0 till 4, 4 till 8 and 8 to 12 you will have these rectangles. Okay, so you have to use the midpoint. Now midpoint, what is the midpoint of 0 to 4? This is right. So 4 plus 0 divided by 2 gives you 2. Between 4 and 8, what is it? You will have the 6. 8 and 12, you will have the 10. So at these values of x, you have to calculate the y values and trying to find out the total amount of the water pumped. Okay, so how do we do it? We will find out R of t because it is the total amount. R of t is explaining us that it is the total amount of water pumped. Let's see here what they are asking. Yes, here. Water is pumped into the pool at the rate of P of t. So we have to write here only P of t. Amount of water pumped into the pool. Okay, so what we are going to do for the midterm, we have x1, f of x1, x2, f of x2, and x3, f of x3. Now the width are same everywhere. So you will write here 4, and here 4. Now here what you will write? F of x1, you will write f of 2, the midpoint. Then your midpoint is 6 between 4 and 8. Then between 8 and 12, your midpoint is 10. So 4. Now f of 2 is what? 46. Then again 4. F of 6 is what? 57. Then 4. F of 10 is what? 62. Write in the calculator and get the answer. If they are not asking you to write the unit, no need to write the unit until they ask you to write it. Next question, the density of the bacteria population is circular petri dish at a distance r centimeters from the center of the dish is given by the differentiable function. You can see here the differentiable function 2 pi 0 to 4 r f of r dr. And you have the 4 subintervals and the right Riemann sum to calculate it. Approximate it. Okay, now what is it? How do you find it out? First of all, write Riemann sum. So when write Riemann sum, read from here, leave the first value. Right? Now the width is different. So 1 minus 0 is 1, 2 minus 1 is 1, 2.5 minus 2 is 0.5, and 4 minus 2.5 is 1.5. Okay, write down. You have to write here 2 pi 0 till 4 r f of r. First of all, write it down. 2 pi as it is because it is outside the integral sign. Now, what you will write? x1 f of x1, right? If you remember, we normally write like this just to show you. x1 f of x1, right? Then x2 f of x2. Then x3 f of x3. And then x4 f of x4. But in your case, we have the r and f of r. So write here r1, r2, r3, r4, and then f of r1, f of r2, f of r3, and f of R4. 2 pi, don't forget to write. Now R1 is 1, 1, 0.5 and 1.5. These are the values you are taking from the R. So it is 1, then again 1, then you have 0.5 and then you will have 1.5. Now write the values which you are taking from here. So first value is 2, second value is 6, third value is 10 and the fourth value is 18. Write it in the calculator and get the answer. Now they are asking whether the approximation found is overestimate or underestimate of the total mass of the bacteria and explain your reasoning. Okay, so you will say that the approximation is an overestimate of the total mass of the bacteria in the petri dish because in the right Riemann sum the values are increasing strictly. So this is how, that's why I told you in the first part that you should either understand or memorize when the area in the right Riemann sum overestimate and when it is underestimate, or even in the left Riemann sum when it is overestimate or underestimate. So memorize that part. It would help you to understand this overestimate and underestimate question. Now next question. Now next question is that an ice sculpture melts in such a way that it can be modeled by a cone in a conical shop and it decreases in the sizes. Radius of the base of the cone is twice differentiable function. Okay, where R of t is measured in centimeters per day and R is measured in centimeters and t is measured in days. Okay, so use the right Riemann sum with 4 sub-intervals. So see 4 sub-intervals. So first of all, if you look here, just check whether it is even intervals or 1, 2, 3, 4. So the width appear to be different for me. 3 minus 0 is 3, 7 minus 3 is 4, 10 minus 7 is 3, and then 12 minus 10 is 2. So we have to calculate this part, right? It means we are trying to find out R of t. So what is the formula? You know the formula, that x1 f of x1 plus x2 f of x2 plus x3 f of x3 plus x4 f of x4. Why we are writing 4 times? Because 4 subintervals. But I told you that rather than writing like this, x1, x2, x3, x4 can be written as t1, t2, t3, t4 because of the x values given in the table as t. So let's write here t1, t2, here t3 and here t4 to understand it better. So x are replaced by t and f of x1 is r prime of t1. R prime of T1, R prime of T2, R prime of T3 and R prime of T4. So this will help you to secure more marks. Okay, now calculate. Now time is 4 different times. 3, 4, 3, 2. So I am replacing 3, 4, 3 and 2. First I replace this. Now I have the y values. So they are saying right Riemann sum. Right Riemann sum, it means I have to go from there and I will leave the first value. So what I am going to write, first value minus 5.0, second value minus 4.4, then minus 3.8 and the last is minus 3.5. Write it in the calculator and get the answer. Okay, if they are not asking to write the unit, do not write. But in all the cases, the unit will be centimeter because you are calculating the radius. Now next question. Now next question is here. So you have to interpret the meaning from 60 to 135 f of t dt first of all. And what is given? A customer of a gas station is pumping gasoline in a gas tank. The rate of flow of gasoline is modeled by the differential function. So it's not the rate of flow, it is gasoline. Okay. And f of t is measured in gallons per second. Time is measured in second. Okay, so what you have to do, first of all, solve it. In order to solve it, they are asking you that how many intervals are there? 3. 60 to 90, 90 to 120, and 120 to 135. So 60 to 90, the width is 30. 90 to 180, the width is 30. And 120 till 135, the width is 15. So first of all, we will write T1, f of T1. T2, f of T2 plus T3, f of T3, because you are using the 3 subintervals, right? Now T1, so the first one is 30, for the second one again 30, and for the third one it's 50. Now we will use the y values. From 60 till 90, okay, from 60 to 90, what you will get? So which Riemann sum? Okay, so you are using from here till here, right? And this is you have to approximate the right Riemann sum. Right Riemann sum means you will go like this. It means you will leave the first value and you will use the last 3 values. Okay, so the first value is 0.15 because you are going to leave this value. So you will write 0.15, 0.1 and 0.05. This is how you will calculate. Now just we have to interpret it. So pause the video and try to get the answer from the video that how can we interpret this value. Write it down so that we can see that you can understand it. Okay, so let's see here. In order to interpret it, as we said that we have to start and we have to take our answer from the question. So what we are doing, it is the flow of gasoline. Okay, what we are trying to measure, we are trying to measure the gasoline. Okay, flow of gasoline, flow of gasoline. Try to find it out. Okay, so we are going to write it is the flow of gasoline between the time interval of 60 to 135. That is all. And the answer should be in gallons. If they are asking for the units, then write the gallons. Otherwise, no need to write the gallons. Do not write gallons per second. Only write the gallons because you are not finding the rate of flow, rate of change of gas. You are only finding the amount of the gas. So do not write the per second.